Okay, we're going to continue on with some more examples of graphing sine and cosine functions. So we'll start again here with a little bit more basic example again, where the amplitude, this A here, is 3, and this is our D, and this is -2, okay? There is nothing in front of X, so that means this is your B. That means your typical period is the same. So remember we talked about period is 360 over B. Well, it's going to be 360. Now again, I can do this either in radians or degrees. I'll just do degrees again for this one. So our typical period is 360 degrees. Phase shift, there is nothing inside parentheses, so that means there is no phase shift. So this is up, down, this is right, left. So if I'm labeling my vertical shift, we're going to go down 2. So it's going to hover around -2, but then from there, it's going to go up 3, down 3. So I'm going to, again, I'll make the middle there, kind of a light line around -2. From there, it is going to, I got to get these right colors here. We're going to go up 3, down 3. All right, so that's my highest point, lowest point. Then I'm going to do my right, left. So if there's no vertical shift, then it's going to start at 0. If there's no vertical shift, it just starts at 0, which is here. It's going to end at 0 plus 60. So it's just going to end at your typical 360. So I'm just going to put 360, 180, 90, 270. And I don't care if you label the original x-axis or you label that blue line. Either one is fine. But again, if I kind of want to put where the end of that is, we're going to start at 0, end at 360. Now it looks a little funny because you can notice my scale is not great. So my bigger half is bigger than my upper half, but we'll just live with that. But now I'm just going to do my regular sine graph, right? Typical sine graph. I'm going to start at 0, end at 0. The middle is 0. And by middle, I mean around that x equals, or y equals -2. I'm going to go up and down, and then this is my graph. Again, I got a little, my scale is a little off, so that's why my bottom looks so much bigger. All right. So let's try another one here. Cosine. So good, we're going to do some cosine here. This is the A value. This is the D value. So the vertical shift is -3. The amplitude is 1/2. So vertical shift of -3. So I don't care how far apart you do these. Notice I'm making a bigger scale because I know I'm only going to be able to go up half, down half from there. So I'm going to just do my lines here. This is my middle line. Everything hovers around -3. And from there, I'm going to go up half. I'm going to go down half, right? So that's like, I don't have to label it, but if this is -2, and this is -4, I'm at -2.5 and -3.5. So there is no new number in front of X, so typical period. I think this one I'll do in radians. This is the last one we did in degrees. You got to be fair to both. So typical is 2 pi, 2 pi over 1. This is our B. And our phase shift, because there's nothing inside of parentheses, there's no phase shift, which means we're going to start at 0. If there's no phase shift, we start at 0. So we're going to start at 0, and we're going to end at 2 pi. Okay, So I'll kind of bring that down a little bit here. So we're going to start here. We're going to end here. This is kind of our halfway, right? But then if we do cosine, so remember this is the cosine shape. So it starts at the top, ends at the top, bottoms out in the middle. So if I plot those points and, you know, again, look at my kind of the box, the yellow is the top and the bottom. The blue is the middle. The green is my start and my end. So I'm going to start at the top, end at the top, and I'm going to bottom out in the middle. Now halfway in between, so at pi over 2 or 90 degrees, that happens there, that happens there. So this graph is over, under, under, over. And that's it. I'm going to keep doing some more examples with more stuff in it. So this has everything in it, which is good. So I'm just going to start out with the easier parts here, which is amplitude and phase shift. So my amplitude, notice this time, is really just a 1. There's nothing in front there of the sign there. So my amplitude, is just a 1. Don't worry about the negative. We're going to just remember that it's because of it's a negative, it's going to be reflected. So I'm just going to make a note of that. Remember, reflected means instead of a hill and a hole, it's going to look like this. So I just have to kind of remember that in the end. So that's my A. This is my D. My vertical shift is a 4. So I'm going to go, let's see if I can move this a little. Oh, good. Whew. Because otherwise I'm going to run out of room. Or at least that gives me a little more space. 1, 2, 3, 4, 5. Okay. So vertical shift, my middle is at 4. So this is the middle. And it's going to go up 1 from there. And it's going to go down 1 from there. So these two parts, go together. These two parts go together. The period. Okay, so the period here is going to finally be different. We're going to do this in degrees. And actually I can see this is in degrees because notice we're adding and subtracting 30. So this is an indicator that we're going to work in degrees, if they don't tell you specifically that it's degrees. So we are going to work in degrees. But first I'm going to do the B. So the B is the period. And remember, we find the period by going 360 over B. So the length of one cycle is 180 degrees. My phase shift, remember I find that by taking everything that's inside of the parentheses. Now I can go to x minus 30. Let me do that a little differently. I don't need that outside parentheses. So everything that's inside parentheses, if we set that equal to 0 and solve, now really if I divide both sides by 2, I get rid of that coefficient right away anyway. So I end up with x minus 30 equals 0. So this is my phase shift, which this is where I'm going to start. That's where I'm going to start. So let me just kind of clarify where we're going to start and end. We're going to start at wherever the phase shift is, which is at 30 degrees. We're going to end at the period plus the phase shift. The period plus the phase shift. So we are going to end at 210. So I'm just going to write this here. I'm going to just go 30. So don't worry too much about, we mostly want to see the start, the end, and the middle. So 30 degrees, 210, Now it's like, oh, great. How do I find what's halfway between 30 and 210? Well, you have to find the average. So if we add those, 240 divided by 2, the halfway point is 120. What's halfway between 30 and 120? Well, if I add those, I get 150 divided by 2, 75, etc. If I add those two, I get 330 divided by 2, which is 165. Okay. I think for sure we should have the 30, the 120, and the 210. So I'm going to just highlight that we're going to start at 30 and we're going to end at 210. And then this is the halfway point. Okay, so you can see the top is and bottom are the yellow, and then the beginning and the end are that first pink and the second pink. And now I'm going to graph it. So this is everything. This has everything in it. It has, well, the amplitude is just 1, but we still have to identify that. It has a different period. It has a phase shift. It has a vertical shift. And don't forget that it's negative. It's reflected. So I'm going to start, sine no matter what, starts in the middle, ends in the middle is the middle. But remember, if it's reflective, instead of a hill and a hole, it's going to go down first and then up. So that's my one cycle. Okay, I could go on from that, but I think we've done enough there with one cycle, don't you think? Okay, we're going to do a couple more here. I can get this going. All right. I think once again, I'll try to make this graph a teeny bit bigger if it'll let me move. There we go. I just want to make the graph bigger if I can. So this time, this is the amplitude. So the amplitude is 1/4. I notice that it's negative. And it's a negative cosine graph. So remember, usually a regular one starts at the top, ends at the top. Well, this is going to start at the bottom, end at the bottom. This is going to be what a negative cosine graph looks like. So we're just going to have to remember that at the end. Vertical shift is 3. So this is our A, this is our D. Now, there's nothing inside parentheses, but what is the number in front of that X? It is an implied 1/3. So this B is equal to 1/3. And remember that your period you find by doing, you do the period over the, the period over B, whatever the period is. We'll go ahead and do this in degrees. There's nothing here that tells us if it's in degrees or radians. So I'll just say we'll do this in degrees. And so we take the typical period, 360, and we divide it by B. So if I multiply the top by 3 and the bottom by 3, this is the length of the period. So I'm going to just start graphing this vertical shift of 3. I still want to make this a little bigger. Okay. So it's going to shift around the 3. 1, 2, 3, 4. I'm going to make this lower. Let's just bring this way down here, because otherwise it's just going to be hard to see everything. So we're going to go 1, 2, 3, 4. So it's around 3. But from there, it just goes up 1/4, down 1/4. Okay, so I'm going to do my midline, which is here. And then 1/4 is going to be something like, 3 1/4 and 2 3/4. So it's going to be super skinny. So now we've taken care of this part, the up-down part. Now we have to do the hard part, which is this. Well, at least if there's no phase shift, we're going to start at 0 degrees. And remember, we always end at the period plus the phase shift. So we take the period plus the phase shift, and well, we end up at 1080. So this is going to be 0. This is going to be 1080. Halfway between 0 and 1080 is 540. Halfway in between 0 and 540. Halfway, and again, if I want to find halfway in between these, I can add them and divide by 2. You're just finding the average. Okay, so I'm going to put that in pink here. Remember, we're starting at 0 and we're ending at 1080. This is the halfway point. And finally, I have to remember this is an upside down cosine graph. So we're going to start at the bottom, end at the bottom. We're going to go at halfway, we're going to be at the top, and it's going to cross halfway in between. So I'm going to make this a teeny bit thinner. This goes under, over, over, under. Okay? So when your teacher's checking this, you just want to make sure that we see that it's hovering around 3, that it looks like it's, going up about a fourth, down about a fourth, that it's starting at 0 and it's ending at 1080. And you can see mine doesn't look exact. I probably went a little bit too far to the right there on that point there. I suppose I could adjust it, but okay, there we go. Something like that. All right, let's just do one last one. One more example, if you'd like to see it. So this one, and here it tells us to do it in radians, but even if it didn't, because there's a pi there, I know it has to be in radians. So amplitude, there is nothing in front of cosine. This is our A, so our amplitude is just 1. This is our D, so that's -3. So I'll just go ahead and start with that. I'm going to go down. I'll give myself plenty of room since I actually have some on my graph here. -3. And I know because the amplitude is 1, I'm going to have to go up 1, down 1. So my midline is -3. From there, I'm going to go up 1, down 1. Okay, that wasn't too bad. But, of course, it's going to get worse here because we've got 2 different things. First of all, we have a B, which is 4. So I'm going to take, my period is always either 360 over B or 2 pi over B. So my B in this case is, if I can get a different color, my B is 4. So if I go 2 over 4, that's the same as pi over 2 for a period. My phase shift I get by going 4x minus pi equals 0, and I'm going to solve for pi, or for x, I'm sorry. And we end at pi over 4. And so, what's going to make this problem hard is fractions. It's always the fractions. So we're basically going to start right up here, since my graph is not up here. We're going to start at where the phase shift is, at pi over 4, and we're going to end at the period plus the phase shift. It's like, oh, great, common denominator. So remember, this is the same as 2 over 4. So 2 over 4 plus 1 over 4 is 3 over 4. That's where it's going to end. So this is pi over 4. This is 3 pi over 4. What's halfway between 1/4 and 3/4? 2/4, or 1/2, okay? And that's probably enough. If you have for sure the beginning, the end, and the middle, you can check with your teacher for sure to see exactly what labels. But now we're going to start at 1/4, end at 3/4. And at least we have just a normal cosine graph going for us. So a normal cosine graph, if I look in, the top is the yellow, bottom is the yellow, the beginning is the green, the end is the green. I guess I could do another green for the middle. Okay, but cosine, we're going to start at the top, end at the top, bottom out in the middle, and then we cross halfway in between. So this is our cosine graph here. So we kind of go over, under, over for that. Okay, so these are challenging. They just take practice. So good luck, and make sure to ask your teachers whenever you need help.